Here we go. Half of 1/4. So if you haven't gotten your notebooks out yet, you need to do that. Is this working? Solving equations. So we've evaluated, we combined like terms, and you need all those things in order to solve an equation. We have 3 parts today, A, B, and C. So the first part is we're actually just going to solve some equations. But I need to tell you that I require some things when solving equations, okay? The first thing you need to do is you need to write down the problem. Okay? So you're going to get to your homework over the weekend, probably Sunday night, early Monday morning. Am I right? Yeah.
Friday night.
Friday night. Okay.
So you can't wake up that early and do it in the morning? Like,
Oh, on Monday? Yeah, don't.
Do
Yeah, don't wait till Monday. Plus, you might forget all of it. So get it done today at lunch. All right. Write down the problem. Okay, you're going to get to the first problem. You actually need to write the equation down. Then what you're going to do is you're going to solve it using column form. You're not working across the page like writing a poem like you do every day. You're working down the page in a column form. Okay? And then you're going to do the thing that you love to do the most, which is show work.
Yes.
Very enthusiastic. You're going to show work. Okay? And if you write just answers, I am not even going to. I'm going to collect it on Monday, and I'm going to look, and I'm going to be like, nope, and I'm going to pass it right back to you. I know, that's harsh, huh? Okay, here we go. Let's do some. So number 1. And some people, what they like to do is they'll take their paper and they'll split it down the middle. They even fold it, and then they work one problem, one problem, one problem. Yeah, that's fine too. Some of them are super easy, and you can do them in your head. I'm fine with that. But once they get complicated, you need to show all the work you can. So like this one, x plus 4 is equal to negative 12. So we're going to solve this. We're going to find out what x is. And this is a pretty easy one-step problem, right? You did this in Algebra 1 or Algebra 1A. And we're going to take this. What we're doing is we have x, and x is like a present, and we're not sure what it is.
Yay.
I know, it's exciting. And we're going to unwrap this present. But when you unwrap a present, you're actually doing the exact opposite order of operations that you did when you wrapped it, right? Take a present, you wrap it, tie the bow, you put a card on it. And what do you have to do? What does your mom make you do every time when you get a present? You have to read the card first.
Yeah.
Oh, I hated that. Out loud. Oh, it's the worst. And then pass it around so people can read it. Yeah. All right, so we are going to subtract 4. And you get x equals negative 16. And then go ahead and put a little circle or box around it so that when you are doing your corrections on Monday, when I put the answers up, you can check right away. And then your work is there so that when I do the problem, if you got it wrong, you can see where you messed up. All right, so that was an easy one. I've insulted you again with how easy this class is. Number 2, you need more of a challenge, right? 24b equals 50. Well, it's not much more of a challenge. That's still a one-step problem. So when we're unwrapping this present of b, we need to find out what it is. So we're going to do the opposite of what's being done to it. So b is being multiplied by 24. We're going to divide by 24, both sides. We're going to reduce our fraction. If you want to write it as a decimal, I'm okay with that too. I prefer fractions, so that would be 25 over 12. And put a little box around it for that. All right, so let's jump up to some problems that are a little bit more challenging. Still things you did in Algebra 1. We're not quite there yet. So we're going to do this one. Negative 27 plus 6y equals 3 times y minus 3. Whoa, that's a big step up, huh? Yeah. Okay, so when solving this, what you need to do is you first need to, someone said it, heard it was the distribute. You have to get rid of those parentheses in order to solve this. I mean, you could start by dividing everything by 3, but nah, you don't want to do that. So go ahead and distribute the 3. And then the left side didn't change at all, so this is what I mean by column form. you're going to write right underneath of it. Work down the page. This is equal to 3y minus 9. That's the second time I did that today, right? Didn't I write 12?
I do that all the time.
For 12? I don't know.
That's why I get probably I
just made a mistake, guys. Okay. So, now let's get our variables together. Would you rather subtract 6y to the other side or subtract 3y? Me too, because I don't like to deal with negatives. So let's subtract 3y to the other side. And you know, it's not wrong if you did it the other way. It's just it's easier this way. So we're left with negative 27. I almost wrote 12. I'm not kidding you. That was so weird. Plus 3y is equal to negative 9. All right, next step. Now we got to get our constant over with the other constant. So we're going to add 27. Did you do it already? Are you done? You're just sitting there. That's all right. That's okay. Or you're just not. Yeah, Preston. Preston's smart. 3y equals, what's negative 9 plus 27? And then finally, last step, divide by 3. Y is 6. Who got that like 5 minutes before I did? Good. A lot of you. But yeah, you know, we got to go slow, make sure everyone's with us, right? Just run ahead. All right, now you're going to try one, and here it is. Number 4. Minus 2, Wyatt. All right, 3 times 2x minus 1 minus 2 times 3x plus 4 equals 11x. Yeah. Oh, wow, yeah. All right, try it. Write it down. Show your work. I'm going to pause the video. The answer is negative 1. I walked around, I saw a couple people had that. So here we go. We're going to distribute the 3. 6x minus 3. And we're going to distribute the negative 2. Negative 6x minus 8. Okay, look at your work. If you didn't get negative 1, maybe that's where you made a mistake. Here we go. I have 6x and a negative 6x are opposites. They cancel each other out. Negative 3 and negative 8 make negative 11. That's a really big negative. And then you divide by 11. So x is negative 1. Who got that? Yay. Okay. All right, so that's part A. And I think you're pretty good. Pretty good at solving, right? Because you did this in Algebra 1, did a little bit in geometry. Pretty good. So we're going to move on to part B. All right, now, part B is all about the special cases that can happen. You know, and we don't do these a lot. A lot of times we like to have an equation that actually works. But sometimes the equation doesn't work and something special happens. So there are 3 things that can happen when you solve an equation. Okay? What can happen is what we just did. When an equation is sometimes true. What that means is you'll get an answer or a couple of answers that work. For these parts up here, the ones we just did, the 4 of them, they're sometimes true. They're only true when x equals negative 1 or x equaled negative 16 or whatever it was. Then they're true. But any other number wouldn't work. So sometimes true are the ones that give you like one solution, stuff like that. All right, then there are 2 other cases. There are equations that can be always true. Always true means that no matter what number you plug in for the variable, it's always going to work. So for example, something like this. 2 times x plus 3 is equal to 2x plus 6. Okay, don't even try and solve this. Let's just look at it. Look at the left side. Distribute that 2 for me. What do you get? 2x plus 6. So if I have 2x plus 6 equals 2x plus 6, it's not going to matter what x I plug in. Everything's going to work because both sides are equal to each other. Okay? All right, something else that could happen is your equation could never be true. Never true. Okay? Yeah, you end up getting answers like 10 equals 3. And you're like, what? That's not true. Okay? I could have something like this. X plus 3 equals x plus 7. What number can you have that you add 3 to it, that you take that same number and you add 7 to it, and they're going to be equal to each other? Nothing. Okay? That would be never true. Nothing works for that. Who came up with that equation? You know, we're not solving for anything. All right, so let me show you what they look like, because you're not going to be able to tell. They look a little just like the regular ones that we do. So number 5.
They're sneaky different.
They are sneaky. They're sneaky bad. 11 plus 3x, so write this down, 11 plus 3x minus 7 equals 6x plus 5 minus 3x. Okay, so it looks like a problem that we're just going to solve like a normal regular equation. So let's start on the left side. On the left side, we need to combine our like terms and clean it up a little bit because we have an 11 and a minus 7. So that becomes, oopsies, that's a 3x, not a bx. 3x plus 4 3x plus 4 equals 3x plus 5. Okay. Maybe you recognize it right here that there's no way you can multiply 3 times a number and add it to 4, and it's going to give you the same thing as 3 times that same number and add it to 5. But if you don't and you kept going and you subtracted 3x, what happens is your variable completely cancels out. Do you see that? Gone on that side, gone on that side, and you get that 4 equals 5. Does 4 equal 5? No. Okay, so I don't want you to write 4 equals 5 as your answer. I want you to write no solution. Or you could write never true. No solution. If you're super lazy or mathematical, you could put a yes. That means the empty set. That means no solution. Nothing works. Okay? I like that the best. But they might ask you, is this always true, sometimes true, or never true? You would say never true. What happened? All right, you try this one. 6x plus 5 minus 2x equals 4 plus 4x plus 1. All right, you try this one and tell me what the answer is going to be. Only have 10 more minutes. You get 4x plus 5 equals 4x plus 5. You can stop right there. If you wanted to keep going and you subtracted 4x, you get 5 equals 5, which is always true. Okay? And so you write, you can write always true. You can write infinite solutions, always true. It's not one solution. Nope. It's an infinite amount of solutions that will work. All real numbers work there. All right, let's move on to the last part.
Yay. No, sad.
I like this
You do? This class likes you. You smile a lot. It's nice. All right, literal equation. Do you smile in all of your classes or just here? Oh, all of them. Oh, good. You start your day with a smile. How many of you guys are just excited to get math out of the way first period, though? Am I right? Yeah.
Yeah, I can't smile.
Oh. I don't smile in English. What do you smile in then? Spanish or French? All right. Solve for a variable in terms of the other variables. So now instead of getting like a number answer, we're going to have an algebraic expression for an answer. So number, what are we on? What was that? 7? 6. Number 7. K is equal to C plus 273. I think this has something to do with kelvins and Celsius. Yep, that's the word. I think. I don't know. I'm not a science person. All right, so what they're going to do is they're going to have this solved for a variable, and they're going to tell you to solve for a different variable. Okay? So they're going to say solve for C. Because maybe they want Celsius instead of kelvins. All right, so we're going to solve for C. So we're going to subtract 273 to the other side. And you get that C equals K minus 273. And that's your answer. Okay, these are equations that you're just kind of rewriting as other different equations that still work. So let me give you another one. Number 8. The area of a triangle. Do you know a very simple area of a triangle? 1/2 base times height, right? Yeah. Area of a triangle is 1/2 base times height. But let's say that instead of area equals stuff, I want to solve for the base. Solve for b. I want the equation in terms of b, or solve for b in terms of all the other stuff. So I need to get the 1/2 and the h over to the other side. I'm going to take it in 2 steps, okay? First thing I'm going to do is get rid of the 1/2. So what should I do to both sides of the equation? Yes. Perfect. Multiply by the reciprocal. She even used math words. That was great. So we're going to multiply both sides by 2. So when I do that, the 1/2 and the 2 equal 1. So I get 2a equals b times h. I'm solving for b. I want b all by itself. What's my last step? I heard it. Divide by h. Oops. Divide by h. There you go. So then we get b equals 2a over h. And that would be our answer. So we're not looking for a number. We don't want to solve it for a number. We're looking for an expression. All right, let's do, I've got 2 more, I think. Number 9. Okay, now they give you stuff that, I don't know, they're not a formula. It's just going to be a bunch of jumbled stuff, but they want you to work on your skills. X over m plus 5 equals y. And we're going to solve for x here. Solve for x. We're actually going to use this next chapter when we have an equation and we're trying to get it into slope-intercept form, y equals mx plus b. We're going to do this, so they're getting you ready for it. All right, now this one only has 2 steps too, but you have to do it in the correct opposite order of operations. So instead of dividing or multiplying first, you add or subtract first. So what's our first step here? Does anyone know? Subtract 5. Preston, you're so smart. All right, subtract 5.
Preston's a genius, man.
Genius status. X over m equals y minus 5. So that's our first step. Get rid of that constant, bring it over to the other side. And now I have one more step. X is being divided by m, so how do I get rid of it? Multiply. Multiply both sides of the equation by m. Be careful though. Make sure on this side you put what? Parentheses. Yes. And sing it if you want to. That's fine too. But put the parentheses there. All right, one more. Number 10. It's nice to end on a number 10. X minus 3 over 3 is equal to a plus b. Now that doesn't mean a thing, you know? There's no formula that says that. But we're going to solve for x here. And this one's a little different than the last one. There's still 2 steps to make sure we do them in the right order. Our first step is to multiply by 3. Okay, but then when we solve the equation, we multiply both sides by 3. Don't forget to put parentheses again. So the 3's reduce, and you get x minus 3 equals, I'm going to move that 3 to the front. It doesn't matter. It just probably makes us feel a little bit better. And then our last step is to add 3. So 3 times a plus b plus 3. Put a little box around it, and we're good to go. All right, so you're going to have some homework to do this weekend on that stuff.